everyone, I'm Chirag and welcome to part 6 of tutorial series on AWS Glue. In this video, I will cover the AWS Glue custom classifier and specifically I will take you through the Grok custom classifier in the later part of this video. Now it is crucial to catalog the data correctly, and to catalog the data correctly, the classifier plays an important role in identifying the structure of the underlying data. And if the inbuilt classifiers do not catalog the data as you need, then there are a couple of options that we can go for, but it is not limited to those. The first option is that we populate or prepare the source data in the format that is supported as a part of the AWS Glue built-in classifiers. Second option could be to catalog the data manually if it is feasible. As a third option, we can create a custom classifier to determine or parse the structure of data the way we want. At the same time, I want you to keep in mind that sometimes the custom classifier also fails, and in that case, you need to change the format of data via some transformations. So let's try to understand the role of classifiers. Now for example, let's consider S3 as the data source, or it could be anything. Now to catalog the data, you will create the crawler which will scan the underlying data and identify the potential columns and their data type. And then it will populate the table definition as a part of the data catalog. Now the question is how the crawler will determine the schema of the data. And the answer is it will determine the schema using the classifiers. So the role of the classifier is to read the data and identify its structure and help to catalog the data correctly. So a short definition of a classifier is the configuration. It could be built-in or custom classifier that is leveraged as a part of the crawler to infer the source data and parse the structure or schema of that data. Now when the crawler finds a classifier that matches the data, the classification string and schema are used in the definition of tables that are written to your AWS Glue data catalog. As a next step, let's see how the crawler chooses the classifier. Now while you define the AWS crawler, one can choose one or more custom classifiers to infer the data, and for built-in classifiers you don't have to do any additional configuration. When the crawler runs, the crawler will start to find the matches in the data store using the custom classifier, and subsequently it will also use other custom classifiers followed by the built-in classifiers if required. Now the question is how the crawler will determine which classifier is a good fit. The answer is a match with each classifier returns the score, which is known as the certainty score. And if any classifier returns a certainty score of 1.0, it means that the crawler is 100% sure that the classifier is a good fit and it can create the correct table definition using that classifier. And with a certainty score of 1.0, the crawler will stop further matching using other classifiers and it will populate the schema using the classifier with a certainty score as 1.0. Now what if none of the custom classifier returns a certainty score of 1.0? In that case, AWS Glue will start the matching using built-in classifiers. Now built-in classifier match will either return a certainty score of 1.0 if there is a match, else it will return a certainty score of 0.0 if the format does not match. Now let's say none of the custom or built-in classifiers returned 1.0 as a certainty score. In that case, AWS Glue will use the classifier that has the highest certainty score. And if none of the classifiers returns a certainty score greater than 0.0, then AWS Glue will return the default classification string of unknown. So I hope that now you have a clear idea about how the classifier is selected for data catalog. Now let's have a look at the types of classifiers. So there are two types of classifier within AWS Glue, which is built-in classifiers and custom classifiers. Here is the list of built-in and custom classifiers that AWS Glue supports as of today. Now with respect to built-in classifiers, there is no additional configuration required to parse the structure of the data. because AWS Glue will internally figure out which built-in classifier to use based on the certainty score. For custom classifiers, there are 4 types available, which are Grok, JSON, XML and CSV custom classifiers. And in general, it can classify the files which are in zip, bzip, gzip, lz4 and snappy compression format. Now let's move on to when should we use a custom classifier. The very simple answer is when the built-in classifier is unable to create the table definition as you need, then you should consider creating and using the custom classifier. Now, as I mentioned at the beginning of the video, I will specifically cover Grok custom classifier. But if you want me to cover JSON, XML and CSV custom classifiers, then please let me know in the comments. So now moving on to the Grok custom classifier. So what is Grok? Grok is a tool to parse textual data using a Grok pattern. And Grok pattern is nothing but the named set of regular expressions. So for example, there is a regular expression pattern that you have defined to parse email addresses, and then you basically go ahead and give the name to that pattern, like for example, email parser, right? So that is nothing but a name set of regular expression. And AWS Glue uses the Grok patterns to determine the schema of the underlying data. Now let's have a look at the syntax of the Grok pattern. The syntax looks like this. It starts with a percentage sign followed by a curly braces, and within curly braces there is a name of the pattern followed by the field name or the alias name separated by colon, and optionally you can define the data type after the alias name, which is again separated by a colon. Now the pattern name here is the name of the pattern that will match the text. For example, if you want to match the month number from the text, then first we will define the regular expression to match the same, and then we will provide the name to that pattern. In this case, the name that we have provided to that pattern is month num, which is followed by a regular expression. Now once you define the pattern, you can use it to define the Grok pattern using the defined syntax, which will be percentage, curly braces, and within curly braces the reference to the defined pattern name followed by the alias name. And the pattern name here is month num, and the alias name can be anything. And optionally, if you want to cast it to integer, then you can define the data type. And in case if you do not define the data type, then by default string data type will be used. And the supported data types are byte, boolean, double, short, int, long and float, and by default it will be string. So I hope that this gave you a simple idea about named regular expression and how to define the Grok pattern using the named regular expression. AWS Glue provides built-in patterns, and if required, the custom pattern can be defined. So for example, if AWS Glue has the month num defined as a part of the built-in patterns, then we can directly use the name of that pattern to define the Grok pattern. But if there is something that you want to match or parse that is not defined as a part of the AWS Glue's built-in pattern, then you have to define the custom pattern like month num followed by the regular expression. Then you can also create the Grok pattern using AWS Glue's built-in patterns and custom patterns. So guys, if you are still confused about the Grok patterns, then don't worry, you will get a clear idea in the upcoming slides where I will cover a few examples. Now let's say we have a log file which looks something like this. Now in this log file we have UUID, we have Windows MAC address, and finally we have the employee ID. Now we want to parse the structure and create the table definition via Grok custom classifier. So let's see how we can use AWS Glue's built-in pattern and custom pattern to parse the structure and define the Grok pattern. Now here is a screenshot that shows a couple of built-in patterns that we will use as a part of the AWS Glue built-in patterns, but there is a long list of AWS Glue built-in patterns which you can refer later on. Now here the keyword you see initially, right, which is highlighted in blue, is nothing but the pattern name, and it is followed by the regular expression which is highlighted in purple. Okay, so this is the method or a syntax to define any custom pattern, right? Now these patterns are defined as a part of the AWS Glue built-in patterns. Now let's say, for example, if we want to parse the username, then we will define the regular expression that you can see, which is highlighted in purple, right? And then we will give some name to that regular expression, for example, username in this case. Now that is nothing but the pattern name. Now here, to parse the structure, the very first thing that we want to parse is the UUID. So if you see, then the pattern to parse UUID is already defined in AWS Glue built-in pattern, which is highlighted in a red box. Then it is same for the Windows Mac as well. We have the built-in patterns to parse or match the Windows Mac. But for employee ID, which is a 7-digit number, there is no built-in pattern within AWS Glue. So in that case, we have to define the custom pattern. Okay. So in simple words, if we have to define the pattern name and the regular expression by ourselves, then it is a custom pattern. Okay, simple enough. Now let's start with the UUID. Now as we know that the pattern for UUID is defined in AWS Glue built-in pattern. So we can use that pattern name to define the Grok pattern. Now if you look under Grok pattern via built-in pattern, in the first row, that is for UUID, the pattern will be percentage curly braces followed by the UUID. Here the UUID is the pattern name, and that will be followed by an alias name, which could be anything. And it will be similar for the Windows Mac address as well, which is right below the UUID. So again, percentage curly braces Windows Mac, which is nothing but the pattern name coming from the AWS Glue built-in patterns, followed by the alias name. Now if we look at the employee ID, then there is no built-in pattern, so we need to define the custom pattern. Under custom pattern for employee ID, the named regular expression is defined. The regular expression that will match the 7-digit employee ID, and the name given to that regular expression is employee ID, hence the custom pattern. And finally, using that custom pattern name, the Grok pattern is defined in the last column in the employee ID row. Okay. Now if we put together all the patterns for individual block, that is for UUID, Windows Mac and employee ID, then it will look like the Grok pattern that is defined in the last row. Okay. So it is UUID Grok pattern space Windows Mac Grok pattern space employee ID Grok pattern. So that will be our final Grok pattern to parse this type of log structure, okay, or this type of text structure. So this was one of the example that how we can define the Grok pattern and how we can use AWS Glue built-in patterns and custom patterns to define the Grok pattern. Now as the next step, we will move on to a log file which we are going to parse in this video as a part of hands-on implementation. So this is the sample data of Apache error log, but I have modified the structure to add the email address in this log. Okay, so I have added random email address within this file. Now let's see how we can catalog this data. So now let's analyze the structure first. So here I have picked one line from this log. So first is the timestamp in square braces, then the log type, which could be an error or notice, or it could be any keyword, followed by the email address, and finally the message. Now let's see which patterns will be used among built-in and custom to define Grok patterns. Now to match the timestamp, we can use built-in plus custom patterns depending on how you want to catalog. For log type, Glue's built-in pattern will work. For email, we need to define the custom pattern, and then on top of that we can define the Grok pattern. For message, it will be built-in pattern. Okay. Now let's go ahead and define the Grok pattern for each block. For timestamps, I have defined the Grok pattern via built-in patterns and custom pattern as well. So if you want to store the day, month, day, time and year separately as a part of the table definition, then use the Grok built-in pattern like this, which I have defined in the first row under Grok pattern via built-in pattern. Okay, but if you want to store the full timestamp in a single column, then you can define the custom pattern using the built-in pattern, which is under custom pattern. Now for log type, it's a built-in pattern and the pattern name is word. Okay, so if you see, then we have defined the square braces followed by the word as the pattern name followed by the alias name, that is log level. Now word pattern will match any alphanumeric characters including underscore. Now how do I know that word pattern will match any alphanumeric characters including underscore? So for that you need to open the AWS documentation and you need to have a look at the regular expression that has been defined as a part of the word pattern name. So from there you will get an idea that what kind of data it will extract or it will match. Now moving along to the email. So there is no built-in pattern for matching emails within AWS Glue. So we have defined the custom pattern and then we have defined the Grok pattern, which is leveraging the custom pattern name. So within custom pattern we have defined the pattern that is get email followed by the regular expression, and then using that custom pattern in the next column we have defined the Grok pattern, which is get email colon alias name, which is email. For message, greedy data built-in pattern is used. So greedy data will match 0 or more of the preceding tokens except for the new line. So this is what the block specific Grok pattern looks like. Now if we want to parse the timestamp into a single block, then we can use final Grok pattern 1. So final Grok pattern 1 is the overall Grok pattern that we will define to parse this overall structure of this log or the text. And in case if you want to split the timestamp into day, month, year and so on as a part of the table definition, that means if we want to create the separate columns for day, month, year and other components, then you can use final Grok pattern 2. So this is the oral Grok pattern that we will be using as a part of the hands-on. So I hope now you have the clear idea that how we can use the built-in pattern to define the Grok pattern, and in case if the built-in pattern is not available to parse specific structure of data, for example email, then how we can define the custom pattern, and using that custom pattern how we can define the Grok pattern. Now moving along, let's have a look at a few important points to keep in mind. Okay, so Grok custom classifier can only process one line at a time. Multiple line patterns are not supported. Line breaks within a pattern are also not supported. So that's a few limitation of Grok custom classifier. In case if you have created the custom classifier and then if you are making any changes into that classifier, then any changes that you will make will not reclassify the previously crawled data. In that case, you have to rerun the crawler. And the final point is that if you are making any changes in the custom classifier, then you need to create the new crawler for it to reflect the changes as a part of the custom classifier. As a part of the hands-on, we will create the crawler without the custom classifier and then we will try to determine the structure using built-in classifier. Okay. As a next step, we will create the Grok custom classifier and then we will again create the crawler with the custom classifier, and finally we will query the data via Athena. On top of this, we will also upload our log file to the S3 bucket and we will also create the database in which we will populate the table definitions. Okay, so that was all the theory that I wanted to cover. Now let's jump to the AWS Management Console. So now once we are within AWS Management Console, we will open S3 first and we will upload the log file that we want to match or parse. Here I am not going to create a new bucket. Instead, I will use the existing bucket, that is AWS Glue Data Catalog Demo or maybe Demo Tutorial Series. And here I am going to create a new folder. I will name it as Apache Log Data and I will create a folder. Now here, as you can see on my screen, this is the log file that I am going to upload. So it has 2000 lines and it's a single file that we are going to parse for the purpose of this video. So I will go back to AWS Management Console. I will open this folder and I will drag and drop Apache log file, that is the error log file, and I will say upload. Now once the data is uploaded, we will move on to the AWS Glue Management Console. And within AWS Glue Console, we will create a new database. So click on Databases from the left panel. Click on Add Database. Give it a name. I will say apache demo db, and I will click on create database. Okay, so whichever table that we will populate will be populated under this particular database. Now as a next step, click on crawlers. Now here we are going to create a crawler. So create crawler, give the crawler name. I will say Apache built-in classifier crawl. So in this crawler, we are not going to attach any custom classifier. We will simply run it with the built-in classifiers. Okay. So give it a name, click on next. Now here you need to click on add a data source. Within data source, we need to configure S3 path. So I will copy the path from here. So it should be the S3 URI. I will paste it over here and then leave rest of the option as it is. Click on add S3 data source. Within custom classifiers, we are not going to configure anything as of now. Click on next. Select the IAM role, which has all the permission that is required to populate the table. So if you are following this video for the first time, then I would recommend that please go through the previous videos of this tutorial series in which I have configured all this IAM role and S3 bucket and database and everything. Okay, so over there you will get the clear idea. But as of now, we will move on with the existing roles. Click on next. Select the target database. So it's going to be the database that we have just created. So it should be Apache demo DB. And here if you want to add the table name prefix, then you can add, I will say built-in, so that we can identify that this table is populated via the built-in classifiers. Okay, and then we will leave rest of the option as it is. Click on next, review all the settings, click on create crawler. Now once the crawler is created, click on run crawler. So now as you can see, the crawler is in the running state. The crawler run is completed, and as you can see under table changes, it says that one table change. Okay, that means one table is populated. So now let's click on databases from the left panel and select the database that we have created. So it's Apache DemoDB in my case, and within this database there is one table with the name built-in hyphen Apache underscore log underscore data. Okay, and this is the S3 location, but here you can see the classification is unknown. So if we recall the slide about how crawler choose classifiers, then in this case none of the built-in classifier was able to parse this data, or none of the built-in classifier was able to determine the structure of this data. So that is the reason the schema is empty and the classification string is unknown. Okay, that means none of the built-in classifiers work for this structure. As a next step, we are going to create the custom classifier. So click on classifiers from the left panel under crawlers. Now once you are within classifiers, click on add classifier, give the classifier name. I will say Apache error log custom classifier. Within classifier type, select Grok because we are going to define or use the Grok patterns. Then under classification, we have to define one string which will be used as the label. Okay, so I will say Apache error parser, and then we have to define the Grok pattern. So for the Grok pattern, I already have that specific input. So here I am going to copy this and paste it over here. So in this case, we are saying that we want to create the separate column for day, month, day, time and year. So that's where we are using this pattern. And as we know that we do not have, or AWS Glue do not have the built-in pattern for the email. So that is where we need to define the custom pattern for parsing or matching the email. So for that we are going to copy this, that is get email, which is nothing but the pattern name, custom pattern name, followed by the regular expression to parse or match the email. Okay. So going back to the AWS Glue, and I will paste the custom pattern under custom patterns, which is optional. Now once you have configured this, click on create. Post creating the custom classifier, click on crawlers. Click on create new crawler, give the crawler name. So I will say custom apache error log. Click on next, add a data source. So again, I'm going to copy this S3 URI. Click on add S3 data source. Now under custom classifiers, we are going to select the classifier that we have just created. So it's Apache error log custom. So I'm going to check this. Okay, you can also attach multiple classifiers, multiple custom classifiers. Okay, now once you are done with this, click on next. Select the IAM role, which provides the permission to this crawler to read the data from S3 and then populate the data as a part of the table definitions. Click on next. The target database would be Apache demo DB in my case, and here I will add the table name prefix. I will say custom hyphen. Click on next. Review the configuration. Click on create crawler. Once you are done creating this, click on run crawler. Now the crawler is in running state, so let's wait for it to populate the table definition. Now the crawler run is completed. So now let's go to the databases and open the database, that is Apache demo DB. And within this database, you can see that there are two tables now. The first one was earlier populated, that is built-in Apache log data. And the second one that is just now populated, that is custom Apache log data. And now you can see under classification that it says that it has used the Apache error parser. Okay, so this is the string that we have provided as an input as a part of the classification. And I have also mentioned that this string will be used as the label. So this is the label under classification. This is the table details. So you can go through it, the input format. So it's textual data, the output format, the serialization library that AWS Glue has used. And then under schema, we should be able to see this, right? So here, as I mentioned earlier, that I want to create the separate column for day, month, day, time, and year. So that's where I have the separate column. And then here we have the log label, email, message. So from where these names are coming? So it's nothing but the alias name that we have defined. So if we look over here, then for day, we have defined the alias name as day. For month, it's month. For time, it's time. For word, it's a log label. So those are all the names that has been populated as a part of the column name. But here you can see the data type for all the columns is string. But let's say you want to modify this, you want to store the month, day as integer, or maybe year as an integer. So how we can do that? So for that, we need to modify the Grok pattern, and then we need to add that optional data type field, right, which is separated by the colon. So let's do that. Let's go to the classifier, and then let's open Apache error log custom. Click on edit. Now here, let's say I want to parse the year in the integer form. Okay, so in that case, I have to add the data type which is separated by colon, followed by the data type which I want as a part of the table definition. So it's integer. Now let me update this. Now one of the drawback that I highlighted, that any update that you make into the existing custom classifier will not be reflected into the existing crawler. So whenever you make any change as a part of the custom classifier, you need to create a new crawler. So let's go ahead and create the new crawler and then reclassify the data. So from here, let's open the crawler that we have just created. So that is custom Apache error log. Select this, click on action, say duplicate crawler, and then it will create the crawler with the hyphen copy as suffix, but you can edit this if you want. So let's say I will add a data type as a prefix. Okay, and as a part of the table prefix, I will say data type. Click on next, review the configuration, create crawler, run this crawler, and let's wait. Now the crawler run is completed. Let's go to the databases and open the database, that is Apache demo DB. And here now we have third table, that is data type Apache log data. Let's open this. And now here you should be able to see the change in data type for the year column. Okay, so now it is the integer data type for the year column. So this is how you can define the custom data type for each of the pattern that you are defining. Okay, and this is how it will populate the table. Now as a next step, let's also create one more classifier. Now here what we did, we basically created the table which has the separate column for day, month, day, time, right? But now I want to store it in a single column as a timestamp. So how we can do that? So let's click on classifiers. Let's add a classifier, give it a name. I will say timestamp custom Apache, something like this. Classifier type will be Grok, and within classification string I will say Apache timestamp. Okay, and then here we need to define the Grok pattern. So I will go back to Visual Studio Code, and here under combined I have this Grok pattern. So I will copy that, I will paste it over here. Now here what we are doing, we are referring this get timestamp, right? So this is nothing but the custom pattern. This get timestamp is not available as a part of the AWS Glue built-in pattern, right? Similar to get email. So now since there is no pattern with the name get timestamp, we have to define the custom pattern for that. So I'm going to copy this. Now instead of only get email, I will also define get timestamp. So here we have defined the get timestamp, which is followed by some pattern, right? So this is nothing but the built-in pattern that we are calling or leveraging, right? And then we are using this custom pattern name as a part of the Grok pattern. And similarly, we have for email. So this is nothing but the combination of built-in patterns plus custom pattern, which is resulting into the final Grok pattern. Okay. So click on create. Now here we have new classifier. Go to crawlers. Let's duplicate one more crawler. So I will select the one that we have just created. Click on action, duplicate crawler. Edit the crawler name. I will only change the prefix from data type to timestamp, for example. And then I will modify step 4. I will change the table name prefix to timestamp so that we can easily identify. Click on next. Click on create crawler and run this crawler. Now the crawler is in running state. So let's wait. The crawler run is completed. Let's click on databases, open the database, that is Apache DemoDB, and reload this. So here we have the fourth table, that is timestamp Apache log data. Let's open this. Oops, so here again we have the separate column name. It's because we have not updated the classifier within our new crawler. So let me do that quickly. I will change the prefix. I will say next. I will remove this Apache error log custom, and instead of that I will attach the timestamp custom Apache custom classifier. Click on next, choose the IAM role, next again. I will change the prefix to timestamp updated, next again, create crawler, run this crawler. The crawler run is completed. Let's click on database, open Apache DemoDB, reload this. Now here we should have the fifth table, that is timestamp updated Apache log. Let's open this, and here we should be able to see that we have a single column for the timestamp, that is string. Then we have log label, email, and message. So guys, this is how you can define the custom classifiers and then use the crawler to populate the table definition for different format of your input data, right, which is not recognized by the built-in classifier or AWS built-in classifiers. So guys, as a next step, let's query these tables using Athena. But before we move on, I would like to request you to please like and share the videos, and please subscribe to the channel if you have already not subscribed. I will really appreciate it. So moving on to the Athena. So search for Athena. and let's open the Athena console. Now once you are within Athena, click on Query Editor from the left panel and then click on Editor. Within data source, select AWS Data Catalog. Within database, select the database that we have created. In my case, it's Apache DemoDB. And here are all the tables which we have created under this database. So first we will query built-in Apache log data. So I will simply click on this three dots and click on preview table. So it will auto generate the select query for us. So it says the syntax error because there is no schema in built-in Apache log data. Okay, that is where it has written the error saying not allowed from relation that has no columns. So now another table that we want to query is custom Apache log data. Click on this dots, say preview table. And here below you should be able to see the data in the specific columns that has been parsed. Okay, so day, month, day, time, year, log label, email and message. Similarly, let's query the updated timestamp table. So that is the last table. So I will say preview table again. And here as you can see, now the overall data of day, month, date, time, year, everything is under timestamp. Then we have log label, email address. So as you can see, the email address looks good in the correct format. And then finally we have the message. So guys, that's all for this video, and I hope you gained good insights and hands-on knowledge about the custom classifier and especially the Grok custom classifier. So guys, that's all for this video. Until that time, if you want me to do tutorial on any use case or service, then please leave them below and I will try my best to come up with the tutorial as soon as possible. And if you have any queries or comments, then again please leave them below and don't forget to like and subscribe to my channel, and see you next time.